Welcome back. In this video, we're going to try to write z, which is equal to 1 plus I tangent alpha, everything over 1 minus I tangent alpha in exponential form. That means we have to write z in the following manner. Z should be the norm of z times e to I alpha. I theta, because here we have this alpha here. So some theta, which is the argument, which the angle that this number makes with the real axis. Okay, here we can simplify. There are many ways to do this job. So we can write z as a plus ib. Okay, so we can first write this one in this form, the algebraic form, and after that we can transform this one into some exponential form, or we can work out by simplifying the tangent alpha as sine alpha over cosine alpha and use Euler's formula, or we can compute the norm first, and after that we're gonna see what we can do. Okay, I don't know which one is better. So so to compute the norm of z, let's do that. So to compute the norm of z, remember that the norm of z is the square root of z times z bar. Okay, here we can have the square root of z, which is 1 plus I tangent alpha over 1 minus I tangent alpha times the conjugate. The conjugate of this number, so it's 1 plus I tangent alpha over 1 minus I tangent alpha. I'm just writing it to simplify. So here I need to find the conjugate of this number. So this is a ratio. Okay, let's write this one more time. So here we have 1 plus I tangent alpha over 1 minus I tangent alpha. So here the conjugate of a ratio is the ratio of the conjugates. Here you can have, okay, let me use a different color. So I'm gonna have 1 plus I tangent alpha, the conjugate, over the conjugate of 1 minus I tangent alpha. Okay, and I now I can do one more step. So here, so this is 1 plus I tangent alpha over 1 minus I tangent alpha. Here, what's the conjugate of this first one? 1 plus I tangent alpha. So here this is real, tangent alpha is real. The conjugate is 1 minus I. So the conjugate is 1 minus I tangent alpha over, what's the conjugate of this one here? 1 minus I tangent alpha. So here this is real, and the conjugate of I is minus I. So therefore we have 1 plus I tangent alpha. Assuming that these numbers are not zero, okay, when tangent is different from minus I. Okay, so here we can see that we can, assuming that this is not zero, this is not zero, and this one with this one we just get 1. Okay, therefore the square root of 1 is just 1, and this means that the norm of z is 1. Okay, so after we found the conjugate, the norm of z, we can now write this one in some simplified form. What we can do is we can use the fact that tangent alpha is sine alpha over cosine alpha. So we have 1 plus I sine alpha over cosine alpha over 1 minus I sine alpha over cosine alpha. So simplifying by the cosine and multiplying, we get cosine alpha plus I sine alpha over cosine alpha minus I sine alpha. Okay, so now we can see this using Euler's formula. So this one on top is just ei alpha, and the one down is e to minus I alpha. And using the rules of exponents, we can write this one as ei alpha times e to I alpha. Okay, this gives me e to 2 alpha, e I to alpha. That means my z is now, I can write it as z the norm of z ei to alpha. But I know the norm is 1, therefore z is just ei to alpha. Okay, so this is a simplified form of this expression. Okay, I can go and simplify it one more time, but I need the exponential form. The algebraic form, I can get it from here. So it's the cosine of 2 alpha plus I sine of 2 alpha. Okay, therefore my number has norm 1 and the argument is 2 alpha. Okay, so that's all I need here. This is I did answer the question. I wrote the z in the exponential form. Okay, this is a quick way of doing that. So here we try to use the definition of the conjugates and the norm to get the result. There is an easier way. We can start by rewriting this one in this form by using what I used here. Okay, and after that, when I do that, I get that z is just this one here, and this one is clear that the norm is 1. Therefore, either ways, I get to the same result. Thank you very much.